Hey everybody, welcome to Algolia DevCon. Today we'll be talking about FinOps for software engineers. I'm your host, Tom Clark. I'm a principal software engineer here at Algolia. I've been with the company for 2.5 years. I have a lot of special interests related to back-end architecture, infrastructure, data analysis, data science, and I've both managed people, managed infrastructure, and have managed the multi-million-dollar cloud budgets for companies like WeWork and Venmo. Here's our agenda. We're going to start off with some common questions that you'll hear in any SaaS company, in any company that heavily relies on cloud spend. Some common questions. We're going to be doing a majority of our time on a hands-on interactive demo that you can follow along to, and then we'll summarize what we learned. So imagine you join some company, some SaaS company, and you have some common questions, and also people within the company have some very common questions. First is, how much does everything cost? With all these cloud virtual machines scaling up and scaling down, cloud costs change from month to month, new products, just what is our total cost? And everybody always wants to know, how can we save money? How can we reduce costs? And then a much harder question to answer is, when will our product cost some sort of target thing, right? If we're doing cost improvements, when will we actually hit some OKR that we want to hit? That one's pretty hard to answer. And the way that we're going to try and answer these questions is with this concept called FinOps. So FinOps is finance plus DevOps. It's finance thinking plus DevOps thinking. And FinOps is a huge topic. A lot of it is access to data. A lot of it is reducing spend. But the thing that I want to focus on for this talk is, how can we use FinOps to actually quantify the business value of all those millions of dollars we're spending on the cloud? And we're going to do this by focusing on the unit economics of our cloud, of our SaaS app, and using those unit economics to do some forecasting. And we're going to get those learnings through data science. Algolia heavily relies on Hex to do our analysis for things like this. Hex is a great tool. It's a Python notebook. It has access to all of our data in Redshift and other databases. And it makes someone like me, a software engineer, access that data easily and then slice and dice it to come up with some interesting analysis that I can give to finance or product. This demo is actually interactive. Here's the link to it. The link should be in chat. I'm in chat right now. I'll be answering questions you might have as you follow along with this talk. So here's our Hex application. Just some basics. Imagine we have our SaaS application is very much modeled off of how Kubernetes operates. We have customers who send us data, and we serve traffic to our customers and users. Those customers access that data. We can put multiple customers on the same server because our application is multi-tenant. We can do this safely. And all of those servers belong in one big Kubernetes cluster. Clusters are geographically distributed, US East, US West, Europe, that sort of thing. And because we're on Kubernetes, if one server is getting a lot of traffic requests, then Kubernetes can auto-scale that one up, add multiple replicas of each individual server within the cluster based on traffic needs. We'll be analyzing unit costs primarily. The way that we do that is we need two kinds of data. We need usage data. This is data that you probably already have, that the finance team definitely uses. Uh, it tells us how much traffic each customer um, used, how much data that they used, and it's doing this every day for every server. We combine that with cost data that we get from our cloud vendor that tells us exactly in very granular detail how much we paid, for bandwidth, how much we paid for storage, how much we paid for virtual machines. When we combine these two, we can compute what's called the unit cost, which is infra cost divided by how many units that we created. Here, we're defining a traffic unit to be 1 million requests. So let's do a basic analysis of our data. Here we see there are some parameters used to generate the data. It seems that over the course of 1 year, 250 customers joined. They asked us to store a certain amount of data, and that cost $200,000 in infrastructure cloud costs. We serve just about the same in terms of traffic units, and infra cost divided by traffic units equals overall unit cost. On any particular day, the best thing we've ever seen is 75 cents. That seems pretty good. On the left side, you see as the year progresses and we get more and more customers, our infrastructure costs has this step function. As we scale up, we need more servers to handle this new data, this larger and larger amounts of data. We're seeing that step function for infra cost. Traffic grows, much more granularly, and it approximates the unit cost. The infra cost approximates our traffic, but very coarsely. When we divide these two, we get unit cost, and our overall unit cost looks like this. So it's extremely high in the beginning, very quickly starts to head towards zero. We only have one cluster, so our average cluster cost, it looks the same. So let's add more customers. What happens when we add more customers? So now we have 500 customers that joined over the course of the same time period. We of course pay more infra because that more customers are spread across now multiple clusters. So here we see that we actually have two clusters. The first one was saturated. Maybe it hit some sort of limit on the amount of data it can store. And so we had new customers are now on a new cluster. The traffic pretty much looks the same up and to the right. We see that the traffic for the first cluster seems to be pretty stable, and the second cluster is still growing. When we look at overall unit costs across just the daily bill, right? How much usage do we have? How much do we pay? Overall unit costs, that graph looks the same. It's hard to tell if there were any changes. But now we can see the average unit cost per cluster. And we see that, yes, when we add a new cluster, we see a regression in this. It is interesting that on August 17th, our costs jumped up, and it's probably until several months later where it starts to stabilize. So that's a very interesting point. When you are adding new infra, and that infra is very expensive, it will take a while before you can rely on the unit cost data to be stable. So definitely don't price your SaaS application by looking at data from right here. Maybe choose right before the scaling event. So these clusters, they're created at different times. But if we graph them by age, then we see that over time they seem to appear to converge on some very similar unit cost value. And so this is a great way to see, sort of race your clusters to see how quickly they can converge. Now let's look at a more advanced analysis here. So we have the same set of data. We're looking at 500 customers, one location. We can, if we view the unit cost data as a logarithmic, we can start to see some behavior even when it's very low. So here, this looks like every time we scale up, our unit costs jump up, and then it takes some amount of time to stabilize. Again, similar to what we saw when we added a new cluster. Be careful when you are looking at your unit costs to make sure that you are not taking an artificially high value that will eventually go down and stabilize. So these big jumps, when we add one new server, we see those jumps are much larger when we add a new cluster. So the overhead, the per cluster overhead, is much, much, much larger than the per server overhead. And that really tells us that we want to saturate our server instances, or rather our clusters, before we create new ones. We can improve unit economics by reducing the size of our server. This big step function over here is because our servers are quite large. They have a terabyte of data. If we reduce the virtual machine size, we can put those customers on a larger number of machines, but those machines are going to be fully saturated, or more likely to be fully saturated. And yes, so now this graph is starting to look more like traffic. And if we reduce the server size further, we should see an improvement to our overall unit costs because we are fully saturating all of those servers. And indeed, our overall unit cost went from $1.02 to 93 cents. And these two graphs look very similar. Now let's look at a more advanced topic. We've reduced the number of customers we have. Our clusters can handle a lot of data, and our servers are gargantuan. So in this scenario, we want to know the behavior of our unit costs. Will they keep improving? Do they stabilize? What can we infer from that? So you might find yourself in a situation where your unit costs seem to be continuously decreasing. When will they peter out? Well, if you graph the unit costs on the left here, we had unit cost over time. If you instead graph unit cost over units, then and you put everything as a log-log plot, you might see this behavior. So this seems to be very linear. You can draw a line through all of these points. You can skewer them, which tells us that if this behavior, this reduction in unit cost continued, it will help us understand when we will hit some target point. So here, Hex lets us take that data from Redshift and compute some data science on it, and we can render a matplotlib graph and do a NumPy linear regression on this. So if this line continues, it tells us that if we wanted to hit 10 cents unit cost, we would have to serve 12 billion units. So that's great. We can tell our product team that, look, if this behavior continues, if we really want to saturate this instance, we might be able to hit some target unit cost at some time in the future. Maybe this 1 cent is impossible, but this very much might be possible. So you can do this sort of advanced analysis with a tool like Hex. So what did we learn? We learned that FinOps truly is for software engineers. It gives us a common language, in this example, unit costs, that we can use, and we can talk to folks in product, folks in finance, other engineers, SREs, our managers. That language is much, much more common throughout your company versus something like virtual machine reservations and Kubernetes auto scaling. So FinOps helps us get a common language so that we all understand and talk about costs the same way. We learned that saving money, that's not the only way that you can improve the health of your business. What we really want to do is we want to improve unit economics. It might mean spending more money, but if that means that you're going to hit some ideal saturation level, then your business is going to be better overall, with improved unit economics, not just reducing how much you pay. One server is not going to change that much, but 10% reduction in unit economics is always going to be helpful. And lastly, we played around with Hex, which is a tool to do interactive data science, and you can easily create applications and share it with your team. You can play around with the link, with the Hex app at this link. We're going to try and keep it up for as long as possible. And if you have any questions, ask it in chat. I'll be on for the rest of the day. And thank you so much.